We're going to start and focus on BAS, macros, and constants, and really just structure our code a little bit nicer from this last lesson that we did. So just doing the normal stuff, copying it up to number 7, and fixing up these numbers. Press the wrong button there. There we go. Try it out. Make sure we didn't break anything here. Did not make the right file. So why not? Okay. Oh. And we do another little test. There we are, all success. We are set up for video 7. So once again, we're gonna restructure the code, and we've got some good files here, but I really want to focus on the new engine. Basically, it's going to be not much more than a collection of functions and things. And I'm just going to call this A64. We'll do it that way. And you'll see as I go on that the include files, the INC, they're still written in assembly, but there's some differences as to how we're going to use them. So the first thing I'm going to do is I'm going to do an include like this, and there is my A64, and again, just it found it, so everything is good, but my file is empty. Okay, well, we have these blocks of code. In this case, just a couple of lines. But in this case, we've got a lot of lines, and it's kind of just overhead. So we're going to move those lines and make them more reusable. And we have an example of macros right here. So this is Peter Lemon's screen NTSC, and he also has a screen PAL. I'm just going to keep it simple. I'm going to stick with the macro screen NTSC. I think these are good parameters, so we're going to stick with those, but I'm going to use my code. You can see here he used the A0 registers and some T0 and kind of mixed it up. I'm going to stick with the code that I wrote. So one of the things that I found through trial and error is that the opening curly brace has to be on the same line as the macro description. So the closing brace can, I just put it on a blank line. I think it makes it easier to see. Stands out a little bit. Okay, and so then I'm going to move that whole block, Control X, and paste. So my syntax highlighting it fails here. And I'm not sure why, but I know that that's all good code. But when you replace it, you need to basically take care of this. So in this case, my width is 320, my height is 200, and the status, just to show you where I'm getting these things from, is in N64 graphics. Here is BPP16, and so that is my status, and my origin, you can see, is this. All right. And now, to be clear, he does the screen NTSC is in the N64 graphics, and we are already including that one here. So I'm going to start and comment it. I forget what things we might have used from there, so we'll find out. Okay. Unrecognized variable, BPP16. So here, these three are good ones. We're going to go ahead and take those and just put those at the top of our file here. And that was it. That's all it took to compile that. So you can see that it cleans the code up very nicely. Brings it all down to a nice little one-liner, but it's not working yet. It compiles, and it will do what we wanted, but they're hard-coded values. If we look here, BPP16 is literally passed in. So this is where we need to use the status parameter that's passed into the macro. Macros are a really helpful tool, but it really matters. You need to understand that these are compile time macros. So they actually make up the code to do what we want before it compiles. So we'll get to see this here. So in order to access that status variable here, we need to just do an open curly status and a close curly. And now it will receive that. And here we can see our width. And so we're just going to do the exact same thing there. And the origin, it replaces this field. So we did the width. Height. This one's a little bit interesting because we'll need it down here. And what we do is we take a look here, and I'm just going to highlight the height parameter in this code. And we can see that it's only used the one time inside this calculation. But just to point out that the width is actually used twice. Once again, this video interface, there's so much going on, so much configurability. So we're just going to go with what Peter Lemon has already done here. So we have the width there, and we really already did it. We just got to replace these hard-coded values. So width goes there, and height goes there. All right. And that is done. Now again, this little 3 lines of code, it'd be nice to to clean those up as well, and we can. So let's go ahead and just make a new macro. Let's see, we'll just call it init. Keep it simple. And we don't need any parameters. Again, the curly brace has to be at the end of the line. Don't need any parameters for this because everything here is really just hard-coded. I'm going to go ahead and cut these lines and paste them in there. And then we need to take this and bring it back. And now we check, make sure it still compiles. Everything is great. And so just to be clear now, so as the assembler is going through, when it finds this macro name, the macros have to be predefined. And so that's why we put this at the top. If we, there's another thing we'll do later that we'll put them at the bottom. And so it can't find it unless it's declared above its usage. So, oops. So that's one of the rules. So we have eliminated our need for that library. So we're just going to remove it. And so finds the macro. It's going to go over here, and it's actually going to copy this code directly into here. And so the thing about macros is if you use the same macro like 10, 20, 30 times, it will copy that exact same block of code, that series of instructions 10, 20, 30 times into your mainline code. Sometimes it's what you want, sometimes it's not. And we'll get into a few more use cases as we go to the next video on the font. So it's going to copy those 3 instructions and essentially insert them right here. And we'll look at this in just a sec as well. And so the same thing applies here. So even though we pass in these parameters, it's literally going to copy this code. It's not going to do like a jump and a link and, go call this function or anything like that. It just gives the assembler a way to grab a block of code. That's pretty much what the macros are doing. So that being said, I'm going to go ahead and leave the draw line function just so that it stays the same, and we'll see the difference. So I believe I've made recently, but it's not a big deal, so we just do that. And I'm going to say debug. Actually, bp set 8 1 2 3 1 1 2 3. And again, that's where our executable code starts. And so here we can see that our first 3 instructions are this init code. And so it really just copied it right over. The T0, the T1, 08, copied it right over. Then those 3 nops that we put in just to break things up, actually those 3 nops, and then we can see that the video registers have started here. And just pointing out here, when you're doing these parameters, sometimes you have to think about them a little bit harder, because it's easy to think, oh, this is a parameter coming in and it's already got its register, it's already got its location, but this is at compile time, not runtime, so it's not a loaded register. And so the thing to point out here is that these parameters, we're using the LI or I think it's mostly the LIs, in order to assign that parameter value to a register. And so, and again, the LIs are a pseudo instruction, and they become an LUI and an ORI, and that's exactly what we're seeing over here. The A440 range is for video, so that first line, A440 is VI base, and then it's an LUI and an ORI, and that is that instruction, and then we store that value. So that's the biggest thing, is that these are not variables on their own, and so you'll need to load them into a register, usually with an LI or an LA. And again, the LI, LA, they're really identical instructions, but it's more of a convenience to you to say, oh, that's an address. And so actually this would be better served as an LA, because the origin is the memory location or address for our frame buffer. So that is a more appropriate instruction, but really they are identical. And here's that line for the frame buffer, A0110, and then it fills in zeros on the bottom half. So let's compile that just to see the difference between the LA and the LI. Really shouldn't be anything, but let's look so we know for sure. And I think I made a goof because in my video 7 folder there was still the old video 6 file. So I just deleted that, and we will run the 7. And we can see there is really no difference. All the way down to here, we see the LUI, load upper immediate, and the OR immediate. And so those instructions are identical, whether it's an LA or an LI. And just to make sure our program does the exact same thing, there is our line. And that is all we need there. So again, this was just a quick little session about reformatting our code and kind of moving it out of the main file so that we could put the things we really cared about there. So as an example, we don't need these 3 NOPs because we can now see a clear difference between that code, and it's already proven code. So it's not that helpful to see that in the debugger. So I thought of something else that I would like to show just as a really useful tidbit. We've started doing this. We're doing the same breakpoint every time we start up MAME. So I thought this would be a good time to show how we can do that all the time. So let's see. So this is our BAS command. Here is our debug command. So we're going to make a little change to this, and we're going to write a little file in here. So we can call this anything that we like, but N64 debug.txt is fine. And this is just handy. So it's a text file, but basically whatever instructions or commands that we give to main when we first start it, we can just type those in advance, and those will automatically run when we start it. So 1, 2, 3, 4. These are my personal defaults. By all means, you can adjust these as you would like. And so this is one that we haven't talked about yet. WP set. And so this is a watch point. It's kind of like a breakpoint, but it's conditional. And for some reason I have it in as this. I don't. It should be fine like this. And comma 4, comma read write. So that's saying if anything is written to this location, the 4-byte range, written or read. I don't think we care about that for quite some time, but it's in there, and it's cool to see a different command is available, that you have more options. And so that is good. And then I'm just double checking on my personal system so that I can get the command line right the first time, if you will. Okay, so we come back here, and we'll just come right here, and we say debug script and n64 debug dot text. So just the name of our file and debug script, and we will see how that works. So just to point out, we actually, it logs every one of those commands that we submitted, and so those are all run, and so all we do is hit F5 to let it go, and we stop at our next breakpoint. And now we're at our executable code. So again, you can add and remove. In fact, for this demonstration, I'm going to I don't know if there's a way to comment in here. I'm going to remove those. I'm actually going to remove that one. I'm going to leave those two. All right. And we can, from here, if we want, we can just do a hard reset. And so this first breakpoint is actually the default. So basically it's about to execute its very first instruction. So it just stops here and says, if you want to do something now, go ahead. And so you can see here also that my debug script it only executed the 2 commands that I had in there. So it really was a hard reset, almost a full restart. And we can just do F5, and we're already at our code. All right.